So if you're just 1 degree off, if you're using that proportional control, because the bearing is non-linear, it goes round to 359, and then 1 degree to the right is a leap of like 360 degrees, so that's non-linear. That's why the first task is get it to steer south. Okay, so it's nice and easy when it's south, but absolutely, as you say, when you're trying to get it north, if it's slightly off, if it's following that same program, it will do a whole loop all the way around and try and get there again, and then all the way around. But obviously that's not what we want. So that is a problem with it trying to steer north. And we have got a solution, and I've written a little piece of code to solve that. Okay, and the piece of code is closest bearing difference. It's actually a function that I've written. All it does is, rather than you doing the subtraction, you put in the bearing, current bearing, comma, goal bearing, and what it will give you is a difference, and it automatically looks out and says, well, if it's going to wrap round 360, I'm going to say, oh, it's -1 instead. So it just works out that bearing, works out that wraparound. So it's only a simple bit of code, actually, but it does solve that problem. So you can start off using the subtraction, and then you can go on to closest bearing difference afterwards. Just kind of introducing these bits, because there is something else I want to introduce as well. And that's the responsiveness of the steering. And this is really the difference between driving a Formula 1 racing car and a Nissan Micra. Okay? So if you're cruising along in a Micra, 40 miles an hour, you don't have to change the steering very quickly, you know, to stay on target. If you're a Formula 1 and you're doing over 100 miles an hour, the steering is very, very responsive. You want to have quick responsiveness to your steering. And some cars have actually got a button that says cruise mode and sports mode, and that actually changes the responsiveness of the steering. So it's just something that I want you to think about. How can you change the responsiveness of the steering? In other words, if it was only 1 degree away from its ideal, let's say you want it to go 180 degrees, but it's 179 degrees, how can you make that steer better than it is? So what we call that is gain. And if you see this piece of code, so that's the basic, okay, that's just going back to the subtraction again. All I've done is the same piece of code, but I've just put ×2. So I've put a gain in there. So all it does, it says, well, if the difference was 1 degree, you know, between 180 and 179, do I steer 1 degree? Or, if I put in ×2, I now steer 2 degrees, so it makes it steer a bit more. So you could put ×10 in there, or ×20, so it makes it more responsive. So it's the difference between someone who drives, you might have been in a car with someone who drives quite nice and you know, it's quite nice steering, or someone who really wrenches a steering wheel, you know, to get caught and you start to feel quite travel sick because they're really responsive with that wheel. That type of person would be someone with a larger gain there. So yes, you can change the gain.